All right, welcome to yet another session where we are going to discuss NCERT solution from binomial theorem. So you can see that 7.1 exercise we are going to complete in this particular video. So question number 1 says that we are having, okay, so question number 1 is having instructions from 1 to 5. Yes, 1 to 5. So all 5 questions you have to do the same thing, right? Easy peasy. Expand each of the expressions in exercises 1 to 5, and this is your expression, right? 1 minus 2x raised to power 5. This is what you have to expand, correct? All right. Okay, perfect. So before that, let me just write down your binomial theorem, right? Binomial expansion. Let me just write down a plus b raised to power n. So it will start with NC0, then it will go with NC1, then we have NC2, then we have NC3, and all the way up to NCN, correct? So these are the coefficients, but we have terms also, right? So it starts with a raised to power 0, sorry, a raised to power n, b raised to power 0. Then a raised to power n minus 1, b raised to power 1. A raised to power n minus 2, b raised to power 2. A raised to power n minus 3, b cube, and a raised to power 0, b raised to power n. Right? So can you see the powers of a are increasing? Sorry, powers of a are decreasing and powers of b are increasing, right? Same thing we are going to do over here. Here n is 5, so just apply that formula because your n is 5 in this particular case, comma a is your 1, comma b is your minus 2x. Okay, let's do that. So it is going to become NC. So how many terms? First of all, let us just understand how many terms will there be in the expansion of 1 minus 2x raised to power 5. So there will be 5 plus 1, that is 6 terms will be there. Okay. So one by one, let's list down the 6 terms. So 5C0, then we have 5C1, 5C2, 5C3, 5C4, 5C5 last. Okay, and it will have 1 raised to power 5 minus 2x raised to power 0 plus 1 raised to power 4 minus 2x raised to power 1 plus 1 raised to power 3 minus 2x square plus 1 square minus 2x power 1 plus 1 and minus, oops, 2x की power we need to increase, right? So cube minus 2x raised to power 4, and lastly we are having 1 raised to power 0 and minus 2x raised to power 5, correct? Okay, and now just expand it. 5C0 is 1, by the way, right? So let me just write down 5C0 is 1, 5C1 is 5, 5C2 is 5 into 4 by 2, that is 10. 5C3 is again 10, right? Same as 5C2. 5C4 is 5, 5C5 is 1. So basically 1, 5, 10, 10, 5, 1. So 1, right, 1, so we don't need to write 1, 1. So minus 2x, so this is 1. Plus 5 times we have minus 2x. Plus 5C2 is 10, by the way. 1 cube is of no significance here, 4x square. Plus 5C3 is again 10 and minus 8x cube. Then we are having 5, 16 x raised to power 4, and then minus 5C5 is 1, 1 raised to power 0 is 1, 32 x raised to power 5. Now the last thing, the final approach, 1 minus 10x plus 40x square minus 80x cube plus 6 5s are 30, and so 16 5s is what? 80. 80x raised to power 4 minus 32x raised to power 5. Okay, so this is how it is. Correct, perfect. All right, so first question done nicely. Similarly, we have to do all the questions. Okay, again. So now let's expand this. Again, 6 terms will be there. 5C0, 5C1, right? Basically 2 by x minus x by 2 raised to power 5 will be equal to 5C0, 5C1, 5C2, 5C3, 5C4, 5c, 5. Remember, the coefficients will be 1, 5, 10, 10, 5, 1. Correct? And now the terms 2 by x raised to power 5 and minus x by 2 raised to power 0 plus 2 by x raised to power 4 minus x by 2 raised to power 1, 1, 1, 1 plus 2 by x raised to power 3 minus x by 2 raised to power 2 plus 2 by x raised to power 2 minus x by 2 raised to power 3. 2 by x raised to power 1 minus x by 2 raised to power 4 plus 2 by x raised to power 0 minus x by 2 raised to power 5. Let's just resolve it. So 1, 2 by x raised to power 5, the 32 by x की power 5 minus x raised to power is done plus 5, then we are having 16 by x की power 4, then we are having minus x by 2 plus 8 by x cube and we are having x square by 4, correct? 5c3, so 4 by x, correct? X cube by 8 plus 2 by x and x raised to power 4 by 16 plus minus x raised to power 5 by 32, correct? Now let's just list down 32 by x raised to power 5. Then we are having 2 and this is 8. 8 5s are 40. So minus 40 upon x cube. This is our next term, third term. 4 2s are 8. So 200. Sorry, 2. 4 2s are 8. So 2. Plus 20 by x plus we are having 5x square. Plus we are having 5 by 8 x cube, right? And last but not the least, x raised to power 5 by 32. These are all 6 terms with us. So 32 by x raised to power 5 minus 40 by x cube, 20 by x minus 5x, not square, it's just x. Then we are having 5 by 8 x cube minus x raised to power 5 by 32. Done, 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 right? So in this question, we have to be a little bit more precise and attentive because one like power mistake can give you a lot of errors. 2x minus 3 raised to power 6. 7 terms will be there. Always one more term will be there. In binomial expansion, n plus 1 terms are involved, right? 6c0, 6c1, 6c2, 6c3, 6c4, 6c5, hold on. 6c5, 6c6, I guess. Okay, fine. Now, 6c0, 2x raised to power 6 plus 6c1, 2x raised to power 5 minus 3 raised to power 1 plus 2x raised to power 4 minus 3 raised to power 2 plus 2x raised to power 3 minus 3 raised to power 3 plus 2x raised to power 2 minus 3 raised to power 4 plus 2x raised to power 1 minus 3 raised to power 5 plus minus 3 raised to power 6. Now one by one let us solve. See, 6c0 is 1, 6c1 is 6, 6c2 is 6 5s are 30, 15. 6c4 is also 15, correct? 6c5 is also 6, 6c6 is 1 and last 6c3 will be 6 into 5 into 4, 3 into 2 into 1, so 20. This is 20, okay. So this is 1, 2x raised to power 6, 2 raised to power 6 will be 64x raised to power 6 plus 6, 32 into minus 3, okay, x raised to power 5 plus 6c2 is 15, 15, 2 raised to power 4 is 16 minus 9 and x raised to power 4 plus 6c3 is 20, 2 cube is 8, 3 cube is minus 27 x cube. plus 64 is again 15 into 2 ka square 4 into 81 x square, and 65 is 6 into 2 into 3 raised to power 5 is 243 with a negative sign obviously, and 3 raised to power 6 will be 9 ka cube. 9 and 81, 729. 729. Perfect. Now one more time, just like solve it a little bit more. Minus 18. 64 x raised to power 6. 64 x raised to power 6 minus, this will be minus 6 3s are 18. 18 into 32, 576 x raised to power 5 plus. Now 15 into 16 into minus 9 will give you 2160. And by the way, this is a positive sign, right? Plus x raised to power 4. Correct. Plus, again, now this time it is negative. 20 into 8 into 27x cube. So 20 into 8 into 27x cube. Hold on. It is 4320. X cube. Perfect. 15 into 4 into 81. 4860 x square minus, this will be having some x, right? 1x, single x. Yeah, so the next term will be 2916 x and plus we have 729. This is our final expression. Okay. Question number 3 also done nicely. Let us move on to the question number 4. All right, expand each of the following expression. Again, same thing. X by 3 plus 1 by x. Thankfully, this time 5 terms. 5 terms I like because it fits in my like space, or yeah. 5C0, 5C1, 5C2, 5C3, 5C4, 5C5. So this is going to be x by 3 ki power 5 plus x by 3 power 4 1 by x plus x by 3 ka cube 1 by x square plus x by 3 square 1 by x cube plus x by 3 1 by x power 4 plus 1 by x raised to power 5. Perfect. Okay. Solve it. So 5C0 is 1. X raised to power 5. 3 raised to power 5 is 243 plus 5 upon 5x raised to power 4 upon 3 raised to power 4 is 81. Okay. But there is 1 by x involved. So that's why this is going to be 3 plus x 5C2 is 10. 10 by 3x plus 5C3 is also 10, and by x 3 ka square is 9. 10 by 9x plus this is 5 by 3 x raised to power 4 plus 1 upon x raised to power 5. This is the final expression. Easy peasy. Now we are getting into it, right? So fourth question done nicely. Now we are having fifth, the last question of this type. Last question says expand each of the expressions in exercise 1 to 5. Again, same thing. X plus 1 by x raised to power 6. Again, 6C0, x raised to power 6 plus 6C1, x raised to power 5 by x plus 6C2, x raised to power 4 by x square, right? 6C3, x raised to power 3 by x cube. 6C4, x square by x4. 6C5, x by x ki power 5. 6C6 by x ki power 6. So this is x ki power 6 plus 6x power 4 plus. Now 6C2 will be 15. 15x square. Then we are having 20. That's it. Plus we are having 15 by x square. So terms are symmetric. Now we can see that there is some symmetricity involved over here, which makes the expression look like a little bit symmetric. Not the exact symmetric, but little bit symmetric. This is how question 5 is done. All right. Now, perfect. We are having question number 6. Perfect. Using binomial theorem, okay. Using binomial theorem, evaluate each of the following. 96 ka cube. So again, we need to write 96 in some format so that it gives you binomial theorem, right? Binomial expansion. 100 minus 4 ka cube can be written. Okay, so you don't have to like cube the 90. You don't have to make a cube of 96. No, right? 100 minus 4 cube. 3C0 and it is 100 cube minus 3C1 100 and square and 4 plus 3C2 100 4 square plus minus 3C3 100 is gone 4 ka cube. Minus sign already adjusted this time. Okay, so this is 100 ka cube 100 0 0 0 0 0. 3C0 is 1. 3C1 is 3 into 100 00 into 4 plus 3C2 is also 3 into 100 into 16 minus 4 ka cube to 64. So 100 0 0 0 0 0 minus 12 0 0 0 0 plus 6 3 4800 minus 64. Now if you solve them, final answer of this particular question would be, let me just write it down, 884736. Yes, 884736 if you solve this. Okay, all right. Now let us move on to the 7th question. Again similar type, 102 raised to power 5, right? So this is 100 plus 2 raised to power 5. Okay, now expand. Again 5C0 100 power 5 plus 5C1 100 ka power 4 2 plus 5C2 100 cube 2 square. Let's not forget. 5C3 100 square 2 cube. 5C4 100 2 raised to power 4 plus 5C5 2 raised to power 5. Let's solve. 5C0 is 1. So 100 raised to power 5. 1 0 0 0 0 0 0 0 plus 5 2s are 10. So 5C1 is 5, 10. So 100 raised to power 4. 0 0 0 0 0 0 0 4 times. And one more extra 0. Plus 5C2 is again 10. So 40. So 100, 40. उसके बाद we are having 0 0 0 0 0 0 plus. Now 5C3 is again 10. And so this is 80. 80 0 0 0 0 plus 5C4 is 5. Right? 5 2s are 10. And 100 is there. And then 2 cubes. So again 8. Right? 2 cube is 8,000. Correct. Plus 32. Finally, you are having answer as, final answer will be, so can you see 32? If you add 8032, right? So 8032. Now 08. So 808032. 3230808. So 04. How many digits? 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 1 0 and here 1 0. Okay, that's it. 1. Yeah, here it will be 1. So 11040. Perfect. 11040. 808032. All right. Next. Question number 7 done. Okay. Now again similar. 101 raised to power 4 is 100 plus 1 raised to power 4, correct? Start. 4C0, 100 raised to power 4 plus C1, 100 cube, 1 power 1 plus 4C2, 100 square, 1 square plus 4C3, 100 plus 4C4, that's it. Okay. So this is 100, 100 raised to power 4, right? 00, 00, 00 plus 4 into 100 का cube. So 400, 00, 00 plus 4C2. This is 6. 6 into 100 plus 4C3 is 400 plus 1. So this is 10406. So 6040, 60401, 04, 01, 04, 06 and 1. So 01, 10, 104, 060, 401. Absolutely right. Question number 8 is also done. Okay, so 7.1 is a lot easier, I feel. 99 raised to power 5 again. This is 99 minus 1 raised to power 5. Sorry, 100 minus 100. 100 minus 1 raised to power 5. Let's expand this. 5C0, 100 raised to power 5 minus 5C1, 100 raised to power 4. 1 raised to power, I'm not writing. 5C2, 100 cube. 100 square. Hold on. 5C0, 100 raised to power 5. 5C1, 100 power 4. Perfect. Plus 5C3, 100 square. Plus 5C2, 100. Plus 5C1, 3, this is 4. And 5C5, that's it. Okay, so 100 raised to power 5. So 100, 00, 00, 00, 00, minus 5, 00, 00, 00, 00. Minus 5C2 is what? 10. So 10, then 00 for cube, 00 for one more cube, 1 more. 5C3 is also 10. So plus 10, 00, 00. 5C4 is 5 plus 500 plus 1. Just solve it out. Let me just directly tell you the final answer. So if you just solve it, because there are minus 95. I have an answer with me. 950 double 9 00499 will be the answer. Okay. All right. Crystal clear. And now next question number 10, with a little bit twist, which they are saying using binomial theorem, indicate which number is larger, 1.1 raised to power 10,000 or 1,000. Okay. So this is something which we don't know. 1,000 to we know. So let us talk about 1.1 raised to power 10,000. Okay. And also they are telling you that you have to use binomial expansion. So 1 plus 0.1 raised to power 10,000. Correct? Let us expand this. So let's start. N is equals to 10,000, right? So 10,000 C0 1 raised to power 10,000 minus, sorry, plus 10,000 C1 0. So 1 raised to power 9,999, right? 0.1 raised to power 1 plus some more terms will be there. Okay. Let's calculate it first. Let's see if we even required the next terms or not. So this we are calculating. This is 1. 10,000 C0 is 1. So this is 1 only. Plus. Now this 10,000 C1 is 10,000 into 0.1 plus some more terms. If I solve the first two terms only, the first two terms are 1,001 plus there are some more terms. Can you see? 1.1 raised to power 10,000 is actually more than 1000. It is absolutely greater than 1000. Can you see? This thing and 1000. Which one is bigger? Obviously 1.1 raised to power 10,000 will be greater than 1000. Right? Okay. Clear? Now, last 4 questions. Okay. Last 4 questions says find a plus b raised to power 4 minus a minus b raised to power 4. Hence, evaluate this. Okay. So yes, a plus b raised to power 4. I guess this color is not visible. A plus b raised to power 4. So 4c0, a raised to power 4 plus 4c1 a cube b plus 4c2 a cube b square. Sorry, a square b square plus 4c3 ab cube plus 4c4 b raised to power 4. A minus b raised to power 4 again. Okay. 4c0 a power 4. So basically alternate plus minus sign will be there. A cube b plus 4c2 a square b square minus 4c3 ab cube plus 4c4 b raised to power 4. Now we need to subtract them, not add, subtract. So the moment you subtract, you will get a plus b ki power 4 minus a minus b ki power 4 equals to, if you subtract these two, the first term will get cancelled out, right? So this is getting cancelled out. This is getting cancelled out. This is getting. So only 2 terms will be left if you watch carefully. So this will be 4c1 a cube b minus minus, double minus. So that's why 2. 4c1 a cube b. Similarly, plus 4c3ab cube. So this is it. So now if you just plug in the value, the root 3 plus root 2 power 4 minus root 3 minus root 2 power 4 will give you twice. Now 4c1 root 3 cube and root 2. Root 3 cube root 2 plus 4c3 root 3 and root 2 cube. Okay, so this is 2, 4c1 is 4, this is 3 root 3 into root 2 plus 4c3 is again 4, so this is 2 root 3 into root 2, correct? So now this 4 and 4 also can be taken, 4 to the 8 can be taken out, 3 then we are having 3 root 6 plus 2 root 6. So finally 5 into 8 into root 6, correct? Because this is 5 root 6. 5 it's a 40. 40 root 6 will be the final answer of this question. Okay, 40 root 6, yes. All right. 11th also done nicely. Now 12th question. 12th question is again on a similar manner. So we need to figure out x plus 1 raised to power 6 and x minus 1 raised to power 6. Okay, and add them. 6c0 x raised to power 6 plus 6c1 x raised to power 5 plus 6c2 x raised to power 4 plus 6c3 x raised to power 3 plus 6c4 x raised to power 2 plus 6c5. Oops. I have to write from here x plus 1 raised to power 6. So 6c0 x raised to power 6, 6c1 x raised to power 5, 6c2 x 4, 6c3 x cube, 6c4 x square, 6c5 x plus 6c6 x power 0. Okay. Now x minus 1 raised to power 6. Okay. So again, now alternate plus minus sign will be there. This is minus, this will be plus, minus, plus, minus, plus. 6c1 x ki power 5, 6c2 x raised to power 4, 6c3 x cube, 6c4 x square, 6c5 x, 6c6. Now we need to add them up, add. So if you add, these terms can get cancelled out. These two also get cancelled out. These two also get cancelled out. So we are left with this, this, this and this. 4 terms are left and obviously 2 similar terms are adding. So twice will be there, right? So 6c0 x की power 6 plus 6c2 x4 plus 6c4 x square and 6c6. Okay. So now again, to find this, root 2 plus 1 की power 6 plus root 2 minus 1 की power 6. You will get twice of 6c0 root 2 power 6 plus 6c2 root 2 power 4 plus 6c4 root 2 power square plus 6c6. So understand what is happening, that all the rational terms are getting formed. 6c0 is 1. Root 2 की power 6 is what? 2 cube, that is 8. 6c2 is 15 and this is 2 square, that is 4 plus 6c4 is 15 into 2 plus 1, right? So this is going to become 2. Then we are having 15 into 4. So 60 and 30. So 90. 9 plus 90. So this is 99 into 2. So obviously it is 198. Perfect. 2 more questions to go to finish the miscellaneous exercise. Okay. Show that 9 raised to power. So this is a typical question. Understand. 9 raised to power n plus 1 minus 8n minus 9 is divisible by 64. That we need to show. So understand 9 raised to power n plus 1 and 8 is also involved. So this 9 raised to power n plus 1 can be written down as 1 plus 8 raised to power n. And now I can apply binomial in this. Okay. So NC0 and 8 raised to power n. 1 raised to power 0, 8 raised to power n plus NC1. Then we are having, okay. No. Actually, we should write 8 plus 1 raised to power n. NC0, 8 raised to power n. No. We were doing right actually. 1 plus 8 raised to power n. NC0, right? 8 raised to power, 8 raised to power 0, 1 raised to power n. Plus NC1, 8 raised to power 1. Plus NC2, 8 ka square and so on. NCN, 8 raised to power n, right? So 1 plus 8 raised to power n can be written down as 9 raised to power n. This NC0, 8 raised to power 0 is 1. The next term, can you see this is 8n? Plus, now understand that every term will have 8 square. So the next term will be 8 cube and so on. So can you see this whole thing will have minimum 2 8 in it. That means 64 can be taken common. So 64 times k I can write, or any integer. If you take 64 common, inside that you will find an integer. So now just look at this. This is what you were looking for. 9 raised to power n minus 8n minus 1 is actually coming out as 64i. So that means that this thing is divisible by 64. That's how we do such questions. Keep that in mind. This is a very good question, important for your competitive exams as well. And we are having the last question, which is, by the way, in form of sigma, but you will realize this is very easy question. This is binomial theorem written directly. Just tell me, 1 plus x raised to power n. Can you just open it? NC0 plus NC1x plus NC2x square plus NC3x cube, and it is going all the way up to NCN x raised to power n. Right? So if you observe, if you just understand this, this is having a lot of terms in summation. So I will convert it into sigma. Sigma, it starts with 0. Can you see 0, 1, 2? This is completely changing, and last it is n. So it is starting with r is equals to 0 and last it is ending with n. So 0 to n, correct? NCR. This r is varying from 0 to n, and after that, can you see something is written, right? NCR, and this is x. So x is having same power as r, right? As this. NC1 x raised to power n, NC2 x square, x raised to power r. So this is sigma r equals to 0 to n NCR x raised to power 1 plus x raised to power n. Now so this is the general summation formula for your binomial expression, general formula. Now let's come back to the question. Can you see this? I just can see that only x here, if I put x equals to 3, I will get the LHS part completely. Put x equals to 3. Yes. The moment you put x equals to 3, 1 plus 3 raised to power n, sigma r equals to 0 to n, 3, then NCR. Yeah. NCR 3 raised to power r. So clearly it is 4 raised to power n. This is equal to 4 raised to 1. Hence proved. Hence proved. So this was the last question from miscellaneous series. I hope that you have enjoyed this session. You have understood all the questions very nicely, very well. And I'll be seeing you in the next. That is Binomial Theorem miscellaneous series. I'll be seeing you. This is Meenamrita signing off. All right. So in this session, we are going to discuss NCERT miscellaneous questions. So there are 6 questions in binomial theorem miscellaneous exercise. Let's start with the very first question. And the question says that, okay, let me just select a pen. Yeah. So question says, if A and B are distinct integers, prove that A minus B is a factor of A raised to power n minus B raised to power n. Okay, whenever n is a positive integer. Okay, so we need to prove that a minus b is a factor of a raised to power n minus b raised to power n, correct? Now they are giving a hint also, although in the examination it is not like short thing that you will get a hint, but they are giving a hint. To prove it, why don't you write a as a minus b plus b. Okay, so what we are going to do that over here is a raised to power n will be equals to a minus b plus b raised to power n, and I'm going to treat this a minus b as one term and b as another term. That's why binomial may you will need two terms, right? Now expand. So this is nc0 a minus b raised to power n and b raised to power 0 plus nc1 a raised to power, a minus b raised to power n minus 1 and b raised to power 1 plus nc2 a minus b raised to power n minus 2 b square, and all the way up to last term will be ncn b raised to power n. Correct? Okay. And a term previous to that would be ncn minus 1 a minus b raised to power 1 b raised to power n minus 1, like that. Okay. Now a raised to power n is right here, and can you see what is this? This is actually b raised to power n because ncn is 1, right? So this is b raised to power n. Let us shift it towards the left hand side because we anyway want a raised to power n minus b raised to power n. So it is already getting created. Now we are having what? A raised to power n minus b raised to power n. So this is nc0 is 1 anyway, so a minus b raised to power n plus nc1 a minus b raised to power n minus 1b. Then nc2 a minus b raised to power n minus 2, and it will go all the way up to nc n minus 1 a minus b b raised to power n minus 1. That's it. The last term is anyway gone. Now just understand one thing. Don't you think that every term on the right hand side is having at least single a minus b? Basically, I can take a minus b common from here, from here, from here, and from here a minus b as well. So a raised to power n minus b raised to power n is equals to a minus b if I take common. Then inside that there will be, I can just basically write k. So hence proved, this is an integer by the way. So hence proved a raised to power n minus b raised to power n is equals to a minus b k. That simply means that a minus b is a factor of a raised to power n minus b raised to power n. Hence proved. First question done. NCERT miscellaneous done. Okay. All right. Now a plus b raised to power 6 and a minus b raised to power 6. Let's expand these two first, just like in the previous exercise, and then evaluate this, right? Okay, so this is 6c0 a raised to power 6 plus 6c1 a raised to power 5b plus 6c2 a raised to power 4b square plus 6c3 a cube b cube plus 6c4 a square b power 4, 6c5 a b5 plus 6c6 b raised to power 6. Okay. And now 6c0 a raised to power 6 minus 6c1 a5 b1 plus alternate sign. It will be plus minus, correct? And obviously you need to subtract. So alternate sign, hold on. 6c3 a cube b cube plus 6c4 a square b4 minus 6c5 a b5 plus 6c6 b raised to power 6. Okay. Now what we need to do is subtract. The moment you subtract, it will become, these two will be gone, these two will be gone, these two will be gone, these two will be gone. So you are left with how many terms? What all terms? This one, and this one. 3 terms will be there twice of 6c1 a5 b1 plus 6c3 a3 b3 plus 6c5 ab5 power. Okay. And this is a plus b raised to power 6 minus a minus b raised to power 6. So here just put a is equals to root 3 plus root 2 raised to power 6 minus root 3 minus root 2 raised to power 6 will be equals to twice. Then 6c1, 6 root 3 raised to power 5 root 2 plus 6c3 is what? 6 into 5 into 4 by 3 into 2 into 1. This is your 6c3, which is, by the way, 20. So this is 20 a cube, the root 3 cube, and root 2 cube, plus 6c5, that is 6, root 3, and root 2 power 5. Okay. 2 is already outside. So this is 6 into 3, root 3 raised to power 5 is 9 root 3. 9 root 3 into root 2 is 9 root 6 plus 20 into, now 3 into 2, 6 into root 6. Perfect. This is 6. 1 root 3 is there. Root 2 raised to power 4 is 2 square. That is 4 into root 6. Correct. 6 can be taken out. So this is 12. 9 root 6 plus 20 root 6 plus 4 root 6. So 24 plus 9 would be 33 into 12 root 6. Okay. All right. So the answer will be 3 to the 6, 396 root 6. Perfect. Okay. All right. So yeah, this is how it is done. Now let's move on to the third question. Similar type of question, somewhat similar, not the exact. So again, a plus b raised to power 4 and a minus b raised to power 4. And we need to add these two. Again, 4c0 a raised to power 4. That's it. Plus 4c1 a cube b plus 4c2 a square b square plus 4c3 a b cube plus 4c4 b raised to power 4. This is 4c0 a raised to power 4 minus. Alternate plus minus sign will be happening over here in the second thing, right? So just copy paste and alternate plus minus sign. And then you have to add right away. So this is going to become, if you add, this is cancel, this is cancel. Twice of. Now you're having 4c0 a power 4 plus 4c2 a square b square plus 4c4 b raised to power 4. Okay. So now just plug in the value. Here, your a is a square. Oops. Now, actually, we have to replace everything by x and y because a is already used. So do one thing, just replace it by x and y, right? So this is x, this is y, this is x minus y. So I will do that here. Let me do it completely only. So twice, I'm not changing it completely. I'm leaving that up to you. Okay, 4c2 x square y square. Because generally, if I'm calculating the formula, what is happening? Now x equals to a square and y is equals to square root a square minus 1. Plug in the value. So now this will be equal to, understand, if you plug in the value, it will be 2, 4c0 is 1, x raised to power 4 to a power 4 plus 4c2 is 6. Yes, x square y square. So a raised to power 4. Sorry, this is a raised to power 8, right? Raised to power y square will be a square minus 1 plus 4c4 is this, so a square minus 1 whole square. That's it. Just open it. 2 a raised to power 8 plus 6 a power 6 minus 6 a power 4 plus a power 4 minus 2a square plus 1. This is your final answer. Just one more time, like polish it. So this is 2 a raised to power 8 plus 6 a raised to power 6 minus 5 a power 4 minus 2a square plus 1 final. Yeah, that's it. This is the third question. Done, done, done. Now we are having the next question. Find an approximation of this using first three terms. Oh, first three terms. Nice. 1 minus 0.01 can be written, right? Instead of 0.99. Perfect. Now expand. Only three terms. 5c0, right? 5c0. 1 raised to power 5. 0.01 minus of raised to power 0. Okay. So basically, yeah, plus minus, alternate plus minus, then 5c1, 1 raised to power 4, 0.01 raised to power 1, plus 5c2, 1 cube, 0.01 square. That's it. Okay. So now this is 1 minus 5 into 0.01 plus 5c2 is what? 10. And this is 0.0001. That's it. 1 minus 0.05 plus this is 0.001. Right? So this is 1.000 and this is 0.05. You have to subtract, by the way, and then add. Subtract 0.05 in this. So clearly this is 1 minus 0.1. 10 minus 5 is 5. Then 9 minus 0 is 9. 0.951. So 0. Hold on. Okay, so this is actually 0.951. Correct? Yes. So 1.5 you have 0.05. Correct, no? Okay, yeah. So now next up we have this question. Expand using binomial theorem. Now you must be wondering, ma'am, this is not even a binomial theorem. It is having three terms. So we'll make it as a binomial theorem. Let me tell you how. 1 plus x by 2 minus 2 by x can be treated as a single term altogether. Now expand. 4c0 and it is going to become 1 raised to power 4 and x by 2 raised to power 4c0 plus 4c1 x by 2 minus 2 by x plus 4c2 x by 2 minus 2 by x square plus 4c3 x by 2 minus 2 by x power 3 plus 4c, okay, might be not visible for you, 4c4 x by 2 minus 2 by x power 4, right? Now 4c0 is 1 plus 4c1 is 4, so 4x by 2, 2x minus 4 to the 8 by x. This is sorted. 4c2 is what? 6. So plus 6 x square by 4 minus 4 by plus 4 by x square minus 2. Okay. Plus then 4c3. 4c3 is 4 only. So cube of this. A minus b whole cube. A cube minus b cube. A cube minus b cube minus 3ab. Product of these two is anyway. So minus 3a minus b. Plus last but not the least power 4 expansion. So it is going to take again x square by 4 plus 4 by x square minus 2 whole square. Correct? So finally 1 plus 2x minus 8 by x plus 3 by 2x square plus 6 4 is 24 by x square minus 12 plus this is going to become x cube by 2 minus 32 by x cube minus this is going to have 6x minus minus plus 4 to the 8 by x plus x. Now a plus b plus c whole square. Now this is something which is going to take some time. Plus x power 4 by 16 a square plus b square. Okay. Plus c square. Minus, sorry, plus 2ab. Plus 2ab is plus 2. And then you are having minus 4 to z to 16x square. And you are having minus 2 to the 4th minus x square. That's it. That's it. This is your final expression. Now you have to like club the like terms together. It is going to be a little bit yeah. So clearly now constant term. Let us talk about constant term. 1, then minus 12. Okay. Then we are having 4 and 2. That's it. Is it? So the constant term will be 4 plus 2, 6. 6 minus 12 is minus 6 plus 1. Minus 5 will be the constant term. Perfect. Term related to x. The 2x. Okay. Then we are having minus 6. So minus 4x overall. That's it. So minus 4x. Perfect. Now x square term. 3 by 2. And then minus x square. 3 by 2 minus 1 is plus 1 by 2 x square. So term related to x square will be this. Then we are having x cube, right? So x cube is x cube by 2. That's it. That's it. There is no term. So x cube by 2 as it is. And now let us talk about by x term. So minus 8 by x and plus 8 by x. Okay, these two are getting cancelled out. And so we are not having, okay, by x wala term, any term. Okay, so this is minus 8x. Hold on. Minus 8x. And this is, how are we getting this? So 4x cube. 4 3s are 12. Okay, and 3 2s are 6 plus 6, 6 4s are 24. Actually, this is 24. Plus 24 and minus 8. Yeah. So plus 24 minus 8 is what? Plus 16 by x. Okay, sorted. Now next, x square by x square term. 24 by x square. Then we are having minus 16 by x square plus 8 upon x square. Correct. Any more terms? Yeah, cube terms. So 32 by x cube, that's it. So minus 32 upon x cube. Okay. And we are having a term x raised to power 4. So this is going to become, okay. Yes, plus 16 by x raised to power 4. This. What about, yeah, and last x raised to power 4 by 16. 1, 2, 3, 4, 5, 6, 7, 8, 9 terms are there. Okay. So this was a little bit like that type of a sum which might like require a lot of attention. Last question of miscellaneous exercise. Expansion of this. Again, trinomial expansion is given, but they are asking using binomial expansion. Okay. What do we do? You know that. 3x square minus 2ax can be taken as one term altogether, plus 3x square can be taken as the another term, whole cube, right? So this is going to become 3c0. 3x square minus 2ax. Okay, power 3. 3a square power 0. Then we are having plus 3c1. 3x square minus 2ax ka square and 3a square. This is the second term. Plus 3c2. 3x square minus 2ax and 3a square whole square. Last 3c3. 3a square whole cube. Okay, let's expand now. 3c0 is anyway 1. So 3x square minus 2ax whole cube. A minus b whole cube. A cube. So 27x power 6 minus b cube. 8a cube x cube. A cube minus b cube minus 3 times a b. A minus b. 3x square minus 2x. That's it. Okay, this is the first term. Plus 3c1, 3 is already there. Now square. So 3x square minus 2ax whole square. So 9x power 4 plus 4a square x square minus you are having minus 2ax, right? So 2 to the 4, 4 3 is 12, ax cube. 3a square plus 3c2 is 3. 3x square minus 2ax, 9a raised to power 4. Plus this is 27a raised to power 6. Okay. 27x raised to power 6 minus 8a cube x cube minus 3 is the 9th, 18ax cube. Okay. 3x square minus 2ax plus, here we are having 9a square. 9a square 9x4 plus 4a square x square minus 12ax cube plus 27a power 4 3x square minus 2ax plus 27a raised to power 6. Okay. So finally we are having 1 by 1, 27x raised to power 6 minus 8a cube x cube. Okay. Can I find any like term just like this? A cube x cube. Yes, I am getting. Yes. This into this. 9 12s are 12 9s are with a negative sign. So 12 into 9. 9 2s are 18. 9 1s are 9. 108. Okay. 108 plus 8. So this is 116. So this is 116 a cube x cube. Perfect. Then we are having ax raised to power 5 from here. Ax raised to power 5. Can I see ax raised to power 5 anywhere? No? Okay. So 18 3s are minus 54 ax raised to power 5. Then we are having plus 36 a square x ki power 4. Correct? Then we are having 9 9s are 81. Again a square x ki power 4 plus 9 4s are 36 a4 x square minus 12 9s are 108 a cube x cube. Perfect. Then we are having 7 3s are 21, 81 a4 x square minus we are having 27 into 2 54 a5 x5 plus 27 a6. Okay. So finally, let me just match all the terms. Whether this 27x power 6 minus 54 ax power 5, then 116 a cube x cube, then sum total of this. So this will be 117 a square x raised to power 4. Okay. All right. And also, let's not forget that, okay, so these two are also like terms, again 117. Then we are having a cube x cube. This I'm getting from where? A cube x cube. 108 a cube x cube. Why I'm getting this repeat thing? Let me check. 36, right? Okay, so 9 fours are 36, a power 4, and after that 9 into 12. So this is already done. Okay, okay. This is already done. Huh? So finally, I'll be writing final expression over here. 27 x raised to power 6 minus 116 a cube x cube minus 54 a x power 5. Then we are having 108 a square x 4. Then we are having, okay, 108 again, a 4x square minus 54 a 5x square plus 27 a power 6. Okay, all right. 108, sorry, 108. So this is actually not 108, but it is 117. Yeah, this is also 117. Yes. Now these two correction. So 117 and 117 a square x power. So this is the final thing. So yes, congratulations. We are done with binomial theorem, all the miscellaneous solutions as well. And I'm going to meet you in the next upcoming chapter. Let me know what do you want to see next on this channel, and I'll break that video for you. This is me, Namrata, signing off. I'll see you all in the next video.